Hello, my name is Eduardo Flores. I am a mechanical engineering major at Washington State University in Pullman, and I worked under Dr. Matthew Whiting in improving our understanding of tree water stress. The motivation behind this is water is a essential yet limited resource. Orchardists want to avoid crop stress and to optimize the quantity and quality of fruit. There are many ways of assessing stress. A few are soil-based assessments, atmospheric assessments, and plant-based assessments. With plant-based assessment, assessing tree stress integrates environmental and soil-based conditions. The pressure chamber is the gold standard in plant-based assessment. The pressure chamber measures the water potential of plant tissues, provides insight into plant water uptake, transpiration, and the overall health of the crop. But it takes time to collect measurements with the pressure chamber. It is time consuming, and when you have to take data collection with the pressure chamber, you have to do it during solar noon to get the best results, and you have to wait around 20 to 30 minutes when you have to bag a leaf. The goal with this was to determine relationships between stem water potential from the pressure chamber and compare that to the soil water content, canopy physiology, and a sensor like an IR camera that measures temperature. In this, we're trying to find relations, so we could potentially replace the pressure chamber with hopefully an IR camera or any other type of test that wouldn't be as time consuming as doing the pressure chamber. For the experimental setup and the data collection, all the data was collected in the second leaf at the WA64 orchard. All of these were done on Honeycrisps. For the data, we collected the data on 3 different days after the water was turned off, those days being Monday, Wednesday, and Friday. And we did them all around the same time of day each day, so from 10 a.m. to 12 p.m. We would first start off with collecting the soil water content at 6 inches from the tree, and then we would go down 6 inches, and from there we would collect our soil samples. Um, then we would weigh them, and then we would take them back to the lab, and then we'd put them to be dried, and after they were dried, we'd collect their weight again. After taking soil samples, we would then use the leaf gas exchange on the tree, and from there we would measure from this we would measure transpiration, and then immediately after using the Cyrus 3 right here, we would then use the Seek thermal IR camera, and we would get the temperature of the leaf with this. And then immediately after that, we would bag the leaf for 15 minutes. And then after the 15 minutes had gone, we would then put it here in the pressure chamber and get the stem water potential for that tree and the leaf. So here we have the results of the soil water content. We can see here that the soil water content was relatively low. We started off at 13.1% and ended off at 9.8%. The soil got progressively drier as the days went on, and we can see that here. The stem water potential also got lower in relation to the soil water content getting lower. Here we started off at 13.1%, and in relation to that, we had a negative 1.46 for the stem water potential. We can jump here to the 5th day, and we see that we have a 9.8% for the soil water content, and if we look here at the stem water potential, we have a negative 2.25. So as the days went on, it did get lower and lower. For the results from the Cyrus, we didn't really find any relations between stem water potential and photosynthesis. Here we can see that this doesn't really show a relationship between the two, and also our R value is pretty low, and it doesn't really indicate that we'd have a strong relationship between the two. We also had pretty much kind of like the same results with the soil water content and stem water potential. The R value was very low, and there was no strong relationship at all between the stem water potential and soil water content. Here we can see um, the one after that is where we started to see a bit of results with the IR camera. The stem water potential over here and the leaf temperatures right here. We do see like a relationship between them, but it's a very weak one. Um, Here you can see like on the days that it was lower, there was a lower stress on the trees, and as it got hotter, there was a bit of a higher stress on the trees. Um, Here we can see a good relationship between the two. It's not a huge one, but it is a good one. What's next for the future of this? I feel like it would be good to gather more data on different types of trees and to replicate the experiment under different conditions to have a bit more variability with this. Um, Also use additional sensors for it that we can find evidence that there's relations between stem water potential and other things. Thank you to the Agate Institution for this opportunity, and also special thank you to Dr. Matthew Whiting and Juan Munguia and Michael Oliver for the help in the data collection. Thank you. I'm open to any questions.